In this video, we are going to learn some basic principles of exponents from chapter 8, specifically 8.2.1 and 8.2.2 from the 8th grade CPM book, okay? So an exponent, just as a quick review, is a little number that you write in the upper right-hand corner of a regular number. And an exponent is basically how many, it tells you how many times to multiply a number by itself. So 3 to the 5th, we say 3 to the 5th. And we can also say 3 to the 5th power, although usually I do not say power, I just say 3 to the 5th to make it a little bit shorter, okay? So this is telling you to multiply 3 by itself 5 times. So 3 times 3 times 3 times 3. Okay, well, that is certainly not the same thing as 3 times 5. 3 times 5 is going to be, actually, let's change this to 5 times 3. Okay, so 5 times 3 is 3 plus 3 plus 3 plus 3 plus 3. Okay, and that equals 15. That's called repeated addition. Multiplication is repeated addition, but exponents are repeated multiplication. Okay, so we have 3 to the 5th being 3 times 3 times 3 times 3 times 3. And the way I solve that is by multiplying all of these numbers together. 27 times 3 is going to be 81, and that's going to be 243. Okay, so 243 is not the same thing as 15. You can see that these are very different. So when you're doing exponents, it's very important to remember you're multiplying, you are not adding, okay? Now, exponents have some cool things that you can do. Exponents are very useful, especially when it comes to scientific notation. We're going to talk about scientific notation in another very short video that I will post. But in this situation, let's take a look at some of the cool patterns we see with exponents. So we have 5 to the 2nd times 5 to the 5th. Well, writing that out in what we call factored form. Remember, a factor is just one of the pieces of a multiplication problem, basically, right? So writing this out in factored form, we're going to have 5 times 5. Okay, that's this part. And then we have 5 times 5 times 5 times 5 times 5, 5 times 5 times 5 times 5 times 5 for the 5 to the 5th. And you can see that when all of these are multiplied together, we could just say that this is really more like 5 to the 1, 2, 3, 4, 5, 6, 7, 5 to the 7th, okay? Similarly, with 2 squared times 2 to the 4th, I would have 2 times 2 times 2, 2, 2, 2. Add all of those up, you get 2 to the 6th, okay? This also works for variables. So I can have x to the 3rd and x to the 5th, 1, 2, 3, 4, 5. Add all of those up and I get x to the 8th. And you can see that the pattern is when the numbers here are the same, you can actually add the exponents together to get the simplified exponent form, okay? Now, if that's confusing to you or if you ever forget that, what you can always do is just write this out in factored form, okay? And then you will be able to very clearly see why it is actually 5 to the 7th, okay? All right, now, something that's really cool about exponents as well is because you're dealing with lots of multiplication, you can use something called the commutative property of multiplication. This is something that we actually learned in 7th grade, but commutative property of multiplication says that when all of the things in an expression are multiplied by each other, you can change the order around, okay? You can switch the order around. You can group it in different ways so that it's easier for you to multiply, okay? So you don't have to go from left to right like with PEMDAS or order of operations. You can actually change up the order. And this is proven here in just this simple example, because 3 times 2 times 3 is going to be 6 times 3, that's 18. Okay, that's the same as 2 times 3 times 3. That would also be 18. Okay, so you can see there that you can change the order of those numbers around. So taking a look at a more complicated example, such as, let's do this one. Okay, we're going to write that in expanded form and then try to simplify it. So this would be 5 times 5 times 1, 2, 3, 4 of those x's multiplied together times 5x. Now, 5x, remember, has a little multiplication symbol in between the 5 and the x. So I'm actually going to write it like this, 5x, like that. Now, the commutative property is amazing because it allows me to group these in a different way, in a way that I want. They're all multiplied by each other. If there was an addition, subtraction, or division sign in there, this does not work. But because they're all multiplied by each other, I can actually say 1, 2, 3, 5 to the third, and I can say 1, 2, 3, 4, 5. So this is 5 to the third times x to the fifth, okay? Makes it really, really easy and expedient, which means fast, to simplify these exponent expressions. Now, let's see another pattern. So in this video, or in this first part, we saw how you can combine these exponents by adding them, okay? And that's proven here, all right? But you can also, this is 822. You can also see another pattern here. So what happens if we take an expression that is to the second power, 5 squared, and then we put parentheses around that, and then we raise that whole thing to the fifth? Well, we would write 5 squared, so 5 times 5, and then we would multiply that by itself 5 times. So 1, 2, 3, 4, 5. Okay? All right. So that's a lot of different 5s. So now you can see that how many 5s are multiplied by each other. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be 5 to the 10th. This is really, really cool. So you can see that a pattern we're noticing is that 2 times 5 is 10. And you can see that in the factored form. Let's do the next number together as well. So 2 squared, well, that would be 2 times 2. And how many times am I multiplying that by itself? 4 times. So 1, 2, 3, 4. And you all know that I don't actually have to write these multiplication dots between the parentheses, because parentheses next to each other already means multiplication, okay? But now I have 2 to the, well, let's see if our pattern works. 2 times 4 is 8. So this should be 2 to the 8th. Does it? 1, 2, 3, 4, 5, 6, 7, 8. Yes, it does. Awesome. So down here, I could write out the factored form, but this should be 3 to the 14th. And this should be x to the 8th. I'm sorry, x to the 5th, x to the 15th. Whoops, added them there for a second. Okay, so this pattern is really helpful and can save you some time. But if you forget how to do this pattern, or if you forget how to do this pattern where you add them, just write out the factored form and it will show you the way, okay? Taking a look down here, this also works with the variables. We saw that with the x cubed to the 5th, but over here I'll do this one as well. So this is x times x times x times y times y, and then we're going to multiply that again because it's squared. So x times x times x times y times y. Okay, so I have 1, 2, 3, 4, 5, 6. So I have x to the 6th, and then I have 1, 2, 3, 4, y to the 4th. Now this is a little bit tricky here, right? Because this means I had 3 times 2 for the x's, okay? And then I had 2 times 2 for the y's. You can see pretty quickly that these are like rules that you could quickly become confused with. So again, I'll say it, that I'll actually end the video with this. If you forget these rules, or if you're confused by them, or if you remember them, but on a test, you're like, is this actually how it works or not? You can always write out the factored form and you will very quickly see if the pattern makes sense or not, okay?